Hello friends, welcome to another video of Zeta Axis, and today we will discuss about greenhouse effect and greenhouse gases. So let's first try to understand what is a greenhouse. A greenhouse is a structure made of glasses. It is used for growing plants. These glass structures, they provide proper temperature and air conditions to help plant growth. Now during daytime, a lot of sunlight enters this greenhouse. It heats the air within the greenhouse. So the air within this greenhouse becomes warm. During night time, the air within this greenhouse is warmer and it is not able to release its heat to the outer atmosphere because glass does not allow the heat to move outside, and therefore the air within this greenhouse is warmer than the air outside the greenhouse, and therefore it helps in plant growth. A very similar mechanism occurs in our atmosphere, where we can see that solar radiation in the form of short wave radiation comes from the sun. It is absorbed by our earth and re-emitted to the atmosphere. Now some of the gases in our atmosphere, they reabsorb this long wave radiation emitted by our earth. When these gases reabsorb this radiation, they again re-release it. When they release it back, some part will go to the outer space while some part will be directed towards our earth. This long wave radiation which is directed towards the earth is again absorbed by our earth and then again released. And this process continuously goes on. You can see that a part of this radiation goes to the outer space and another part is again directed back to our earth. So this process where the heat released by our earth is absorbed by the gases in the atmosphere and again transferred back to the earth is what is greenhouse effect. Now this process helps us to maintain temperature of our atmosphere. We can see that the average temperature of our atmosphere is 15 degrees Celsius, and it is mainly because of this effect. If there were no greenhouse gases in our atmosphere, then the solar radiation which comes from the sun would be absorbed by our earth and then released in the form of long wave radiation, and these long wave radiation would directly escape to space without being redirected towards our earth. Now because of this, the average temperature will become minus 18 degrees Celsius, because during the night times there will be extreme temperatures. As there is no heating by the greenhouse gases, the temperature of earth during the night times would fall to extreme levels. It could go from minus 40 to minus 50 degrees Celsius, thus bringing the average temperature to minus 18 degrees Celsius. So you can see that without the greenhouse gases, the life on earth would be very difficult. Now let's see what happens if the amount of greenhouse gases in our atmosphere increases. If the amount of greenhouse gases increases in our atmosphere, then the long wave radiation emitted from the earth will be more absorbed by the atmosphere, and there will be more redirection of this radiation towards our earth, therefore retaining more amount of heat released. So the proportion of heat that is released from the earth and then redirected towards earth will increase, and the amount of heat lost to the space will decrease, therefore increasing the amount of heat in the atmosphere and thus increasing the temperature of our atmosphere. In this chart we can see the whole range of radiations that is present in our atmosphere. This section gives the solar radiation coming from the earth, while this section gives the radiation that is emitted by our earth. Here we can see that it starts from ultraviolet range, then we have visual range. Visual range is the 7 color lights that we see through our eyes. Then there is this infrared range, and you can see that our earth emits all the radiation in the lower infrared range. Here you can see some of the greenhouse gases, where water vapor is able to absorb the radiations coming from the sun as well as the radiation emitted by our earth. Similarly, here is carbon dioxide. We can see that it absorbs a very small proportion of solar radiation coming from sun, while it absorbs a greater proportion of radiation emitted by our earth. Oxygen and ozone, we know that absorb the UV radiation. They also absorb some of the radiation emitted by our earth. Then there is methane, which hardly absorbs any incoming solar radiation, but it absorbs a lot of outgoing radiations. There is again nitrogen oxides, which absorbs the radiation emitted by our earth. So you can see that how these greenhouse gases absorb in different ranges of radiation. Here is the list of natural greenhouse gases, and here is the list of man-made greenhouse gases. You can see that water vapor tops these natural greenhouse gases, then carbon dioxide, nitrous oxide, methane and ozone. While in the man-made gases we have mainly CFCs, which are used as coolants, then HCFC, which were again used as a replacement for CFCs, but they are also a greenhouse gas. Then there is this perfluorocarbon, sulfur hexafluoride and HFCs. Here we will see the global warming potential of each of these gases. Now global warming potential means that if we take 1 unit of this gas, then how much global warming will it provide? Now for this comparison, carbon dioxide is considered as the benchmark, which means that the amount of global warming provided by 1 unit of carbon dioxide is equal to 1, because it is a benchmark. Now if we take methane, and if we take 1 unit of methane gas, then we see that the global warming provided by 1 unit of methane is 21 times than the global warming provided by 1 unit of carbon dioxide. So this is 21 times more effective. Similarly, nitrous oxide provides 310 times more heat compared to the carbon dioxide. And we can see that this amount keeps on increasing. But these gases are present in a very small fraction, while carbon dioxide is present in a very large fraction compared to these gases. Therefore, the effect of carbon dioxide is higher. If the proportion of these gases were to increase in our atmosphere, then it will have severe consequences. Now let's see what is the atmospheric lifetime. Remember, not only the global warming potential, but the lifetime in the atmosphere is also an important factor. If a gas is quickly removed from the atmosphere, then it will have less impact. So here we can see that carbon dioxide can go on in our atmosphere from 50 to 200 years. Methane has a very short life in our atmosphere, that is from 12 to 17 years. We can see that this lifetime increases with the man-made gases. We can see that these gases are very stable and therefore they can live on for thousands of years in our atmosphere. Now what are the major sources for these gases? So we can see that carbon dioxide is mainly produced from fossil fuel combustion, land use conversion, cement production, while methane is from rice fields, waste dumps, livestock and wetlands. Nitrous oxide mainly comes from fertilizer production as well as use of fertilizer in our agriculture. CFCs come from liquid coolants and foams. HFCs are used in cooling systems. Again, HCFCs are also used as liquid coolants. We see that perfluorocarbon is used in production of aluminium and semiconductors, while sulfur hexafluoride is used in electric power transmission as well as in production of manganese. These are the major sources of these gases. Now why greenhouse gas is a very concern these days? If we see a record of past 2000 years, we will see that the amount of carbon dioxide, the amount of nitrous oxide and the amount of methane in our atmosphere has increased to a very drastic level. You can see that here these are the normal levels of each of these gases, but here when we come to present, we see that these gases proportion in our atmosphere has increased very steeply, and that is why it is a concern. Even in last 50 years, you will see that the greenhouse gases like carbon dioxide has continuously increased. Similarly, the methane proportion in our atmosphere has also increased from 1975. The nitrous oxide is also continuously increasing, and the man-made gases are also increasing in our atmosphere. So we can see that all these greenhouse gases, their amount in our atmosphere is increasing, and that is why it is a severe issue. If we see the combined heating influence, we can see that the heating influence of carbon dioxide is more than any other gas, because the amount of carbon dioxide in our atmosphere is higher compared to all these gases. We can see that the global warming potential of carbon dioxide is 1, but because its proportion is high, therefore the heating effect is much higher. We can see that after carbon dioxide there is methane, and then there is nitrous oxide. And we can see here that compared to 1990s, the amount of heating provided by these gases has also increased. So the global warming is increasing because of the increasing of these gases. So who are the top emitter countries which emit these greenhouse gases? Now if we see simply, then in 2018 the highest emitter was China, followed by US, EU, India, Russia, Japan and Brazil. We can see that India emits as much as 6.5% of GHG of total GHG emitted in the world. So a lot of countries demand India to reduce their GHG proportion. But here is a paradox. Here you can see that the cumulative emission from 1751 to 2017, and we can see that now the amount of gas emitted, greenhouse gases emitted by US and EU is much higher, while the amount of greenhouse gas emitted by India is only 3% if we take the cumulative amount. So we can see that present GHG is mainly because of US and EU works. Therefore, to ask India to reduce its proportion is unfair because most of the gases have been produced by these two regions. In fact, if we see the per capita emission of greenhouse gases, we can see that India, even in current data, is lagging behind all other countries. US has a very high per capita emission. Now let's see each of these greenhouse gases one by one and try to understand what are their source and how can they be reduced. Water vapor, whose proportion varies from 0 to 4%. We have already seen that it is a very good greenhouse gas. Here, this section describes the incoming solar radiation, while this section describes the radiation going out from our Earth. We can see that water vapor absorbs radiation coming from sun as well as the radiation released by our Earth, and therefore it is the most effective greenhouse gas. The major source of water vapor is the hydrological cycle. You can see that the water is evaporated, it is condensed to form clouds, and then rain occurs and it comes back to our Earth. So this is a cycle through which water vapor is maintained in our atmosphere. Now human activities have very less effect on the amount of water vapor in the atmosphere. Now here if we see, then the vapor, this water vapor is mainly concentrated in the equatorial region, because in the equatorial region there is more sunlight, hence more evaporation. In these regions there is less sunlight and the temperature is also cooler, therefore there is less water evaporation. When we go higher in our atmosphere, we will see that the density or amount of water vapor also decreases continuously. In fact, 99% of water vapor is located within our troposphere. The next important greenhouse gas is carbon dioxide. Again, we can see from here that carbon dioxide absorbs very less amount of incoming solar radiation. You can consider this very less amount or almost nil, because the amount of radiation coming from sun in this zone is very less. So it mainly absorbs the radiation which is emitted by our Earth. Here you can see the concentration of CO2 in our atmosphere, and we can see that over 800 years this was the range in which the carbon dioxide was there in our atmosphere, but currently the carbon dioxide concentration is over here. So you can see that there is a very large increase in the proportion of carbon dioxide in our atmosphere. Now we have already seen that carbon dioxide has maximum effect on global warming because of the large proportion of carbon dioxide compared to other gases. So what are the major sources of this carbon dioxide? We can see that the most important source is this electricity and heat generation. Then there is transportation, manufacturing or construction, building uses, industrial processes, land use, fugitive emissions, waste and agriculture. So we know that for production of electricity we need to burn coal or any other gas like natural gas. And when these coal or other fuels are burned, they release CO2 in the atmosphere. And therefore the process of energy generation releases a lot of carbon dioxide in the atmosphere. Transportation is another source of release of carbon dioxide in the atmosphere. Here we see that CO2 is released from these vehicles. The residential buildings as well as the commercial buildings also emit carbon dioxide in the atmosphere because of their light requirements, heating requirements and other requirements. Now there are certain processes in the industries which directly emit carbon dioxide in the atmosphere. The cement industry, the process which is used in the cement industry directly emits CO2. So this is different from the CO2 emitted by burning fuel. This emission comes by the process involved in producing cement. And similarly, the petrochemical industries and chemical industries also emit CO2 because there are certain processes used in these factories or used in these industries which directly emit CO2. Deforestation also increases CO2 in the atmosphere because the dead plants are decomposed and their decomposition releases carbon dioxide in the atmosphere. Here are the sources of carbon dioxide in our atmosphere. We know that electricity generation uses coal and natural gas, and in process it emits CO2. Then there is transportation, where fuel is used for passenger and good transport, and during the burning of these fuels we get carbon dioxide in the atmosphere. Then there are industries like cement industries, metal industries or chemical industries. These industries uses chemical processes, and during these chemical processes we get carbon dioxide, and this carbon dioxide is released in the atmosphere. Then there is land use conversion. We see that draining wetlands as well as deforestation also releases carbon dioxide in the atmosphere, because when we drain wetlands there is biomass under the water. This biomass, when is exposed, it is decomposed, and this decomposition process releases carbon dioxide in the atmosphere. Building heating also releases carbon dioxide in the atmosphere. So how can we reduce this emission? There are certain generic steps like increasing efficiency of fossil-based power plants. So we can increase their efficiency. We can see that advanced technology is used for production of electricity. Fuel switching, we can use natural gas which releases less amount of CO2 compared to coal. Renewable energy is definitely an option. Then increasing efficiency of devices. So the devices which we use in our home, their efficiency can also be increased. We can use 5-star mark products. We can use better quality refrigerators or air conditioners which require less energy. Nuclear energy is definitely an option for reducing carbon dioxide, but it has some other effects. Carbon capture and sequestration is a process where we capture CO2 from the atmosphere and then we use it to deposit somewhere. We will discuss this topic in another video. We can also reduce carbon dioxide by increasing energy efficiency of buildings as well as vehicles which we are using. We can use more efficient electrical appliances. Energy conversion, like using public transport or better urban planning, which means that the houses should be located near the zones of industries, therefore less transport is required. We can reduce the personal energy uses by using less appliances as well as turning off lights when it is not required. Fuel switching, renewable energy, fuels with lower carbon contents in power plants can be used. Now let's see the next important greenhouse gas, that is methane. And here you can see that the fraction of methane in atmosphere is much less compared to carbon dioxide. Now we can see that the global heating provided by this methane is second only to carbon dioxide. The global warming potential of methane is much higher than carbon dioxide, but because the amount of methane in the atmosphere is less, therefore the overall heating effect of methane is less compared to carbon dioxide. Now in last 800,000 years, this was the concentration of methane in atmosphere. But in recent years, the concentration of methane has climbed to this point. So you can see that there is a large increase, almost 4 times increase in the amount of methane in our atmosphere. So what are the major sources of methane in our atmosphere? The first is agriculture. Then comes fugitive emissions, that is emissions occurring from the pipelines by mistake or leakages. Then there is waste, buildings giving out land use change and forestry, transportation, manufacturing, electricity and industrial processes. So why do agriculture release this much amount of methane? To understand that, let's see how decomposition occurs. Here consider this is a biomass and it is decomposed in the presence of oxygen. So you will see that not much gases are produced while decomposing in the presence of oxygen. But when this biomass is underwater, you can see that oxygen cannot reach this biomass. In this condition, the decomposition will occur through anaerobic process. And when anaerobic decomposition occurs, we see a lot of methane is released. So it is because of this anaerobic decomposition, a lot of methane is released. So what we see in our paddy fields or rice fields, that there is a lot of water, and beneath this water there is a lot of biomass. And this biomass, when it is decomposed, we see that anaerobic decomposition occurs and methane is released in the atmosphere. Similarly, in the wetlands, we see that the plant leaves, some animals, they fall in these wetlands and they die. And when they are decomposed, we see again anaerobic decomposition occurring and methane is released in the atmosphere. Similarly, when wastewater is released to the rivers or oceans, these wastewater include a lot of biomass which they carry from the cities. These biomass or organic things, when they are decomposed, they again release methane as well as nitrous oxide to the atmosphere. Therefore, the release of wastewater in oceans or rivers also releases methane in the atmosphere. Moreover, when there are manure piles like this, as we have seen in our villages, so there is again anaerobic decomposition in this, because manure is formed by decomposition, and because in this heap there is less amount of oxygen in the deeper parts, and therefore there is anaerobic decomposition and we see release of methane and nitrous oxide. Landfills also releases methane. We know that in cities the waste from the cities is collected and it is dumped in an area which is called a landfill. Now in this landfill, in the starting years we see aerobic decomposition, but as time passes anaerobic decomposition starts, because in the lower layers the reach of oxygen decreases, and therefore by decomposition of those biomass which are in the deeper parts we see release of methane. The cattle that we have, they also release a lot of methane, and the process is called enteric fermentation because of the mechanism occurring in their digestive tracts. So we see that in their digestive tracts there are certain organisms. These organisms help in digestion of plant cells. The plant cells has cellulose which cannot be digested by humans, but because of these organisms in the digestive tract of these animals, they can digest the plant cells. But when they try to digest the plant cells, they release a lot of methane. This methane is produced in their digestive tract, and slowly this gas passes through their digestive tract and is released in the atmosphere. A very similar process occurs with the termite as well. So termites also emit methane in the atmosphere. We know that a lot of natural gas as well as petroleum is transferred using these pipelines. Now when you are transferring natural gas, there is methane involved in it, and at certain locations or at certain times there are leakages in these gases and they emit methane in the atmosphere. So this kind of emission is called fugitive emission from oil and gas. The oil fields from which the oil is extracted, it also has some methane with it. But generally the quantity of methane is so small that it is not economically viable to extract this methane, and therefore these companies, they burn this methane, because it is not possible to extract the oil without releasing this methane, and this process is called flaring, and this also releases methane in the atmosphere. So here we can see the major sources of methane in our atmosphere. So for agriculture we see rice fields, swamps as well as animal manures. For livestock we know that their digestion process, it releases methane in the atmosphere. Energy and industries, we know that processing and storage of natural gas as well as crude oil also releases methane, as well as when we do coal mining, even then with the coal beds we find methane, and this is released in the atmosphere when we are trying to get the coal from these coal mines. Waste dumps also produce methane because of anaerobic decomposition. In fact, we have seen that waste, when it is discharged to water, it releases methane in the atmosphere. Land use changes like draining of swamp regions also releases methane in the atmosphere, because there is a lot of half decomposed biomass in those regions, and when they are exposed they release methane. So how can we reduce the emission of methane to the atmosphere? In industries we can upgrade the equipment which is used to store or produce the gases or oils, because we know that during the production of oil as well as coal we get some methane which is released to the atmosphere. So we can capture those methane. In agriculture we can have better manure management. We know that heaping of the manure also releases methane in the atmosphere, and there can be modifications to what we give to animals for eating. So animal feed can also help us in reducing methane in the atmosphere. Waste from homes and businesses, they can be properly processed before discharging them to landfills or water. Now let's see nitrous oxide, which is also an important greenhouse gas. And if we see sector wise, then nitrous oxide is mainly emitted by the process of agriculture. We know that in normal circumstances, there are denitrifying bacteria in the soil which release nitrogen to the atmosphere, but this amount is very less. These bacteria, they generally release nitrous oxide, and it is a very slow process and they emit a very small amount. But when we add this nitrous fertilizers to the soil, the amount of nitrogen in the soil increases, and therefore these denitrifying bacteria can emit a lot of nitrous oxide to the atmosphere. So the proportion or the amount of nitrous oxide released by adding these fertilizers increases. Moreover, transportation also emits nitrous oxide. You've already seen when waste is disposed in the water, then it goes anaerobic decomposition and it releases nitrous oxide along with methane. Similarly, when there is a heap of manure, there is anaerobic decomposition which releases methane and nitrous oxides. Here we see major sources of nitrous oxide in the atmosphere. Agriculture is the most important source of nitrous oxide, and we see that if we add artificial fertilizers to the soil, the amount of nitrous oxide released by the soil increases. Manure management also releases nitrous oxide, because when there is a heap of manure, then there is anaerobic decomposition and methane is released. Burning of agriculture residues also emits nitrous oxide. Then there is fuel combustion in transports. Industries also release nitrous oxide during this process. Then there is wastewater as well as waste material. So when it is disposed of, it also releases nitrous oxide. And then there is soil bacteria which naturally emit nitrous oxide in the atmosphere. How do we reduce it? We reduce it by decreasing the amount of nitrogen based fertilizers. We use efficiently these fertilizers, and there is better manure management. Reducing fuel combustion is one way to reduce this nitrous oxide emission, and then we can promote public transport and we can use catalytic converters in our vehicles. Industries can also do some technological upgrades. They can perform fuel switching which do not emit nitrous oxide. Now let's come to ozone. We know that ozone has higher concentration in stratosphere where it absorbs UV rays. But in the troposphere there is small fraction of ozone, and here it acts as a pollutant. In fact, it also acts as a greenhouse gas. Tropospheric ozone is not directly emitted in the atmosphere, which means that it is not produced by any process like burning or transport or in any industrial process, but it is formed by chemical reaction between nitrogen oxides and volatile organic compounds. But this ozone acts as GHG, and we can see its effect in photochemical smog. Tropospheric ozone can be reduced, and the best way to reduce is by using catalytic converters as well as using better quality of fuel in our transport. Fluorinated gases. These are the man-made gases. We have seen here that these are the man-made gases which are greenhouse gases, and these are the major sources of these greenhouse gases. We can see that CFCs, HFCs, HCFCs, they are mainly used in cooling solutions. Perfluorocarbon is used in production of aluminium and semiconductor, while sulfur hexafluoride is used in production of magnesium as well as power transmissions. They are produced only in industries, and there is no natural source of these gases in the atmosphere. So here we can see the mechanism by which we can reduce the emission of these gases in the atmosphere. So instead of using those ozone depleting and greenhouse gases, we can use other substitutes which has lower global warming potential, and there is technical improvements in the device to reduce the leakage of these gases in the atmosphere. In the industries, we should prefer recycling of these gases and optimizing their production process. Therefore, less amount is required as well as less leakage happens in the atmosphere. Electricity transmission and distribution, they can ensure that there is less leakage, because this SF6 is used in several power transmission devices and there is leakage from them. So they should do proper repair of these devices, and then they should ensure that there is very less leakage. If possible, recycling of the equipments could be done. We can extract the SF6 from them and then reuse them. We can use alternative technologies which does not require these gases. In transportation, which uses AC systems or cooling systems, then we can reduce the leakages. We should try to reduce the leakages, and we should also try to find alternative refrigerants. I hope you have liked our video on greenhouse gases, and if you have liked, then please do not forget to like, subscribe and share, and do follow us on our social media handles. Thank you.